Dear students, in the last topic of Unit 4, we are going to concentrate on Q-learning and what are the different applications of reinforcement learning. Now, what do you mean by Q-learning? So, Q in Q-learning stands for quality, and it is one of the type of the reinforcement learning algorithm. Now, Q-learning algorithm is called as a off-policy RL algorithm. Why it is called as a off-policy RL algorithm is here in a particular state, I will take the action A and I will try to find out what is the reward that I am getting. And according to that, there is one matrix called as a Q table that I am going to update. So like that for every action, whatever value I'm getting that I'm going to store in the table. Now I will choose only the actions which are giving me maximum value. Means the set of the actions are not fixed. The strategy is not fixed. Policy is not predefined. That's why it is called as a off policy algorithm. As an example, now let us find out how many tourists are coming to particular holiday spot. Now there are some holiday spots which will be good for summer season. There are some holiday spots which are good for winter season. There are some spots which are good for monsoon season. So based on season, the number of tourists visiting a particular holiday spot is changing. So which we are going to store in a table, and according to that, how much business will be generated, how much a financial benefit will be generated, that we can estimate. So such algorithms are called as a off policy RL algorithm, and Q learning is one of such algorithm. Now here, how we can define the flowchart for Q learning is initially with the assumed value, the Q table will be initialized. Then we will select an action to perform. Then we will perform that action and we will find out how much reward we are getting. What is the feedback for that action? How the evaluation for that action is done. And according to that, we will update the Q table. Now listen, as I told you, the same holiday spot will have different number of the tourist visit based on the season. So for every season, the number of the tourists are changing. Means for every season, the reward will change. So according to that, Q table will be updated. Now another type of the algorithm is called as SARSA. Means what? State action reward. Again, continue your chain. State action. Means what we are doing is here it is called as a on policy algorithm. Means algorithm which is whole and sole depending on the policy. Policy which is containing a set of the actions, and only those actions should be executed in the given sequence. You can't change the set of the action. You can't skip some particular action. Whole and sole, you have to follow the current policy. So the main difference between the Q learning and SARSA is Q learning is off policy while the SARSA is on policy. In Q learning, we are trying to select only those actions which are giving me maximum reward. And according to that, I am doing the continuous updations in Q table. So SARSA is based on a tuple which is called as SARS dash A dash. Means original state, in that original state, original action, then the reward observed, then the upcoming state and upcoming action. Okay. Now, the third type of the algorithm is DQL. Means what? Deep Q learning. Means the Q learning is taking help of the neural network for approximating the Q value. Means instead of defining the Q table, instead of defining a matrix, it is storing the Q values using a neural network. Now, what is the main objective of Q learning is in a policy, I want to find out the actions which are giving me maximum reward. So for that purpose, I am taking help of the Bellman equation. Now what the Bellman equation is telling us is we are using a discount factor, and by taking particular action A in current state, what is the reward we are getting, and what was the reward in the previous state? We are trying to find out the maximum in between these two. So the same we are applying here. So here, the probability of action A in the state S to generate the new state is multiplied with the value of new state and whatever reward we got in the current state that we are adding. Now here, how we are getting the maximum? The maximum of whatever rewards we got for the actions till now, that we have to consider here. So what the Q in Q learning stands for? Q is what? Quality. Now in reinforcement learning, what is our quality? The quality is defined by the award. That award we want maximum. So the actions which are giving me the maximum award, those actions I want to store in a sequence. And this sequence is defining me my policy. So the rewards will be stored in Q table, that is a matrix. So it is storing the pair of the state and action. So the Q table is a reference to select the best action based on the Q values. Now, is there any difference between reinforcement learning and supervised learning? Yes. In reinforcement learning, we are not using labeled data, but supervising learning needs a labeled data set. That is a basic difference. Okay. In reinforcement learning, the agent is continuously interacting with environment. So he is learning through that interaction only. He is learning through that experience only. He is learning through the mistakes only. But in supervised learning algorithm, we are doing training through which the agent is learning. So reinforcement learning works more like human brain to take the decision. But supervised learning needs supervision of particular guide. Now, in reinforcement learning, there is no specific training and testing phase. But in supervised learning, first training should be performed and then only testing can be performed. Now, reinforcement learning helps you to take the decisions sequentially. There is a chain of actions. There is a chain of the decisions you are taking. But in supervised learning, decision means what? The prediction that will be done during the prediction phase. Means when the training and testing is over, then you will go for making the decision based on the predicted value. So this is what the difference between the reinforcement learning and supervised learning. Now, what are the real-time applications of reinforcement learning? So these are all areas where your reinforcement learning will be used. Now, the first one, robotics. You know, the robot navigation, the walking, everything. You need reinforcement learning. Now, control. Now, where you need the control? During the telecommunication, drones, then a helicopter, pilot, admission control, etc. Then in game playing, the best example is the tic-tac-toe and chess. Means whether you will win or lose the game based on your current action. That is decided by the agent. Now in chemistry, to optimize the particular chemical reactions. In business, to plan a strategy when you are launching a new product, when you are doing the modifications in the current product, when you want to give some discount on the product, or you want to apply some policy for the employees or customers or shareholders, etc. Then in manufacturing also to automate your task, mainly in automobiles, where you have to pick up a heavy load and store it in some containers. Then in finance sector to evaluate the trading strategies. Means when you are investing today in particular share, what reward you will get in future. So these all can be decided using reinforcement learning. So this is the end of your unit 4. I hope you have understood the definition of reinforcement learning, the different terms we are using in a reinforcement learning, what is Markov decision process, what is Bellman equation, what is Q learning, what is the difference between the reinforcement learning and supervised learning, and what are the different real-time applications of reinforcement learning, what are its type, what are its approaches. So I hope you understood the unit. Thank you.